Okay, so in this video, we're going to briefly just go over how to read and interpret the data from a solubility curve. So some important things just kind of get right off the start is that on my y-axis here, I have the grams of solute per 100 grams of water. So that means that this data that you're going to gather here is only good for if your volume of solvent, your volume of water is 100 grams. The nice thing about it being 100 grams, though, is that this is pretty easily scalable, meaning that if I needed to know how much solute dissolved in 200 grams or 300 grams or 500 grams, I would just figure it out for 100 and then multiply by 2, 3, or 5 respectively. So I can use this for all sorts of volumes, even though it is based in 100 grams of water. Across the bottom, I have my temperature in degrees Celsius from 0 to 100. And then I have the various lines for my substances labeled with their name. And what you're going to notice is that most things, as the temperature increases, the solubility increases. There are very few things where it actually decreases as temperature increases. And in particular, we notice that gases, especially, their solubility will decrease as temperature increases. So think about what we know about movement of molecules, that with gases, gas particles move incredibly fast. And as we increase the temperature, we increase their rate of motion. So they're essentially just harder to corral and shove into a liquid when they get hotter. And so the solubility actually will decrease as the temperature goes up because they're just harder to control. Whereas with our solids, as the water heats up, they're going to be able to accept and dissolve more molecules. And the example I always use with this is think about what happens when you make sweet tea, right? Almost everyone has made sweet tea. This is North Carolina after all. So when you make sweet tea, you boil your water, you steep your tea bags, you always make sure that you put the sugar in while the tea is hot so that it will dissolve. If you run off, get busy doing something, come back, and your tea has cooled too much, when you try to dump that same amount of sugar in, you end up getting that layer of sugar sludge at the bottom because the solubility has decreased because the temperature's decreased. So now less sugar is going to be able to dissolve. So again, as I increase the temperature for solids, I'm going to see that most of the time my solubility will increase. All right. So there's a few basic questions that you would be asked relative to a solubility curve. So the first one would be to determine what type of solution. Well, when we talk about types of solutions, there are three types. You have a saturated solution, you have a supersaturated solution, and you have an unsaturated solution. So a saturated solution occurs when I have just the perfect amount of solute per solvent molecule. And that is what's represented by the lines here. So if I have my two data points, like for example, with the KNO3, at 50 degrees Celsius, exactly 80 grams of KNO3 dissolves. So at 50 degrees Celsius, when exactly 80 grams of KNO3 dissolves, I form a saturated solution. That is the exact amount of solute that the solvent can accept. No more, no less. It is perfect. It is just like this thin line. If I were to put 81 grams, it would no longer be saturated because it would now be more than the solvent can accept. 79 grams would be not enough. So it's just this exact line as I go up my graph. An unsaturated solution contains less than the maximum amount that can possibly dissolve. So for example, if I only had 70 grams of KNO3 at 50, notice how my data point is lying below my line. So I would call that an unsaturated solution. Conversely, if I said I had 110 grams of KNO3 at 50 degrees Celsius, notice how my data point is significantly above my line. This would be a supersaturated solution. So if you're on the line, saturated. If you're above the line, supersaturated. If you're below the line, you're unsaturated. There are some numerical kind of data points you can also take for this. One of them would be when I ask for what is the solubility. So the solubility of a substance includes the grams of solute over the 100 grams of water. So, for example, we'll stick with this KNO3 one just because it's easy to read. If I asked, what's the solubility of KNO3 at, let's pick an easy one to read, at 70 degrees Celsius. So it looks like it's just slightly below the 130. So I could say that at 70 degrees Celsius, the solubility of KNO3 is 128 grams of KNO3 per 100 grams of H2O. And that's what I would write if I was asked for the solubility. Okay, if I was just asked for how many grams would dissolve at that temperature, I could just then say 128. But if it's asked for specifically solubility, I have to have both parts to get credit. You could also just be asked for temperature or mass information. So, for example, if I said at 80 degrees Celsius, how many grams of ammonium chloride dissolve? So I go to 80, I see where it intersects that line, I draw over, it'd be like 63 grams of NH4Cl. Or I could be asked for temperature information. If I said, at what temperature does 138 grams of potassium iodide dissolve? So 138 grams, potassium iodide, about 10 degrees Celsius. You could also be asked to compare the solubility of two samples. At what temperature do equal amounts of sodium nitrate and potassium nitrate dissolve? I would look and see where their two lines intersect. And then I would look up the temperature, so like 72 degrees. So it's basic graph reading. But the biggest thing that you need to realize is your data point above the line is supersaturated. Your data point under the line is unsaturated. Your data point exactly on the line is saturated. Oh, and then the other thing I wanted to point out, we talked about if it was more than 100 grams, what to do. Let's do an example of that. So let's see. How many grams of NH4Cl would dissolve in 200 grams of water at 90 degrees Celsius? So I come to my 90 degrees Celsius, I go to my ammonium chloride, it's 70 grams. So if it's 70 in 100, then I would double that up and it would be 140 grams of NH4Cl if it was in 200, okay? If it was 300, I would multiply by 3. If it was 400, I'd multiply by 4. Okay, so that's your basic information on how to read a solubility curve.